All right, so today we're going to be doing limiting reactions. And so this problem does the whole gambit from start to finish. So we know we have 35 grams of sodium hydroxide and 44 grams of phosphoric acid. Okay, and it says that they are neutralized. Well, that means it's going to be a double replacement reaction. Remember, neutralize is that special form of double replacement where you put an acid and a base, react them together, and get a salt and a water. So let's first get that chemical reaction. Sodium hydroxide plus phosphoric acid is going to give me, remember, cation swap, so sodium's now going to be with the phosphate, Na3PO4, and H is now going to be with the OH, which you can write it as HOH or H2O, whichever one you're familiar with. I like doing HOH because that just helps me keep the poly together here for balancing, but it does not matter what you're going to do. 3 sodiums, 1 phosphate, 1 phosphate, 3 hydrogens, 3 hydroxides. So that gives me 3 waters. Okay, we don't need to do state symbols today, but if it asked you for state symbols or if the reaction happened or not, use your state symbols to make sure. But since it's a neutralization reaction and we created water, we do know the reaction is going to happen because it neutralized something. We just don't know if this guy is going to be aqueous or a precipitate, a solid. Okay, he's balanced. I'm going to put all my ones in front so that it's clear when I'm doing my mole ratios. 35 grams of sodium hydroxide. And then 44 grams of phosphoric acid. So I write it above there. Notice you're going to have one number for each reactant because you're trying to find out which guy is going to run out first. Don't assume it's the 35. You actually have to do the reaction. You find any product that you want. Okay. I'm going to use sodium phosphate, and I'm going to go to grams because that way I can also do the yield, which is in part B. So now that we have that product set up, now we got to do our stoich. Stoich of a reactant to the grams of the product that you want. So I'm going to do a stoich of 35 grams of sodium hydroxide, and I'm going to get to grams of sodium phosphate. And I'm going to do a second stoich of the other reactant, 44 grams of phosphoric acid to grams of the product. Okay, so don't think of it as limiting reactions are crazy. They're just double the work or triple the work if you had 3 reactants. What's our pathway from grams to grams? It's grams to moles. Grams goes on the bottom, moles of sodium hydroxide on the top. And then mole ratio. What we know, sodium hydroxide goes on the bottom. What we want to find, sodium phosphate goes on the top. There are 3 sodium hydroxides for every 1 sodium phosphate. And now we got to then finally get it back in gram form. So we're going to use the molar mass of the sodium phosphate this time. Same thing for number 2. Grams on the bottom, moles, but this time moles of phosphoric acid on the top. And then in this case, we're going from phosphoric acid to sodium phosphate. So moles of phosphoric acid on the bottom, moles of sodium phosphate on the top. And now we're going to change from moles of sodium phosphate to grams of sodium phosphate. Now let me slide that up. Why did I lay out both of those at the same time? Because you can notice that the similarities here, grams on the bottom, you're just going to get the grams of sodium hydroxide here and grams of phosphoric acid here. Moles of sodium hydroxide, moles of hydrogen phosphate, but they're both going to sodium phosphate. And they both have the exact same last step because you're going from moles of sodium phosphate to grams of sodium phosphate. So some of these numbers you're going to be able to use multiple times, and that's going to help you out as well. So let's calculate those molar masses. All right, so sodium hydroxide. Since you guys have seen molar mass multiple times now, I'm just going to do this off camera, but I'm going to tell you what I'm doing. 22.99 plus 16.00 plus 1.01. Because remember, you always go to 2 sig figs. And that's going to give us a 40.00 grams and 1 mole of sodium hydroxide. So how about sodium phosphate? 22.99 times 3 plus phosphorus, which is 30.97, plus 4 oxygens at 16. 163.94. Okay, and then on our bottom one, we need phosphoric acid, 1.01 times 3 plus 30.97 plus 16 times 4, 98.00 grams and 1 mole. And let's see our last one of sodium phosphate. That's the same, 163.94, 1 mole. Sodium phosphate has a 1 for its coefficient, so 1 mole of sodium phosphate equals 1 mole of phosphoric acid. All right, 35 times 1 times 1 times 163.94 divided by, and make sure you use your brackets here because you are dividing by 2 things. If you don't use your brackets, then this guy is going to think it's a multiply, and your answer is going to be off by a factor of 9. So make sure you use brackets. And you should get 47.82 sig figs, so 48 grams. And that's of the sodium phosphate. So 35 grams of sodium hydroxide makes 48 grams of sodium phosphate. What about the other guy? 44 times 1 times 1 times 163.94 divided by 98. I didn't need brackets that time because I was only have one thing. 2 sig figs, 74 grams. So 44 grams of phosphoric acid gives me 74. So in this case, if I had a bigger number, it did in fact give me a bigger number, but that isn't always. Which guy is limiting? The one that produces the least. So that means my sodium hydroxide is my limiting reactant, and this guy is my excess reactant. A lot of people then want to say that sodium phosphate is your limiting reactant. Limiting reactant. What guy was limited? This is what's going to deal with your yield. Okay? So your limiting reactant is sodium hydroxide. Your excess reactant is phosphoric acid. So we have one more stoich to do now. Okay, it's got to go to moles. So this part's is still the same, 1 mole NaOH. So you can steal a lot of things. 40.00 grams and 1 mole of sodium hydroxide. And instead of going to the product, I think I might have said product when I said, you're going to stoich the limiting reactant to the excess reactant. So you're stoiching sodium hydroxide to phosphoric acid. Okay. So in this case, we're going to have 3 moles of sodium hydroxide on the bottom, because remember, that's what we know, and that's what needs to cancel. Moles of sodium hydroxide in the top cancels moles of sodium hydroxide in the bottom. We're stoiching to the excess reactant, so that's 1 mole of phosphoric acid. And we got to change that guy into grams again. So 1 mole of H3PO4, we can steal that, is 98.00 grams. So again, we were able to steal a lot of that. We just had to revise our mole ratio. And what do we get? 35 times 1 times 1 times 98 divided by the quantity of 40 times 3. 2 sig figs, 29 grams of phosphoric acid. So that means when I do a reaction with 35 grams of sodium hydroxide, the exact amount of phosphoric acid that I need is 29 grams because I stoiched it from one to the other. 35 grams of sodium hydroxide equals 29 grams of phosphoric acid. So that's your exact needed. But I have to figure out my excess. What wasn't needed? 44 minus 29. 15 grams in excess. Okay, that 15 grams wasn't needed at all because I only needed 29 for the experiment. And lastly, it asks me for what's the percent yield. And after doing all that, the percent yield, that's a lot faster. Part over whole, or the experimental amount over the theoretical amount. Okay? And so it gave us a theoretical yield. Remember, it can't be this guy because we never made it that far. We ran out of sodium hydroxide at 48. That's why he's the limiting reaction. He limited how far the reaction can go. So this is our theoretical yield. The stoich always gives us a theoretical. And they were only able to get 40 grams when they did the experiment. So 40 over 48 is 0.83. And we just need to change that to a percentage. 83% is our percent yield.